Hello, this is my second attempt at making a calculator watch. This one is not a graphical calculator like the first one, because this one was inspired by this display. This display is from a 1970s Polish calculator, the Unitra Brda calculator, which had one of the early LED displays. It is a so-called bubble display, so you can see that the segments are very small and the digits are magnified by those bubbles, so they don't seem as small as they actually are. This display is not very efficient compared with modern LED displays. So a modern LED display would be much bigger and consume about the same amount of current, but here it's very small. But I really liked the way it looks. It's you can't really see it on the camera probably, but in real life it's very mesmerizing, this red color. It looks very nice. So this watch has a global on-off switch here, which turns on the power. This is the USB port for programming it. It has two touch buttons, which are resistive touch buttons. You need to touch both the metal case here and this round contact. There are two of them, and there is a rotary encoder, which also acts as a button. So the default mode on this calculator is the clock mode. To make it show the time, you twist this rotary encoder by one step, and it will show the time for a few seconds. If this is to conserve the battery. The battery is rechargeable. It is a LiPo battery, 200 milliamp hours, and you charge it with this USB port. You can just use a normal phone charger, but you need this cable of a mini USB. If you want it to show the time constantly, you press the encoder, and now it will indefinitely stay in the clock mode. You can get out of it and just put it back to sleep by touching this button. If you want to check the battery voltage, you use this touch button here. It says it's 3.8 volts, so it's pretty much full. But there are also different modes on this calculator. If you press both the touch buttons, you get into the menu, and here you can get into the four different modes of this watch. So the default mode is the clock. The next one is set hour, which sets the time. So when you enter it, you can set the time here, and then you press it to accept the hours and the minutes, and it's done. You can also set an alarm, because it has a built-in buzzer. So we need to turn it on, and let's set it to this time. So you can see that the alarm works. It displays this ALA. It stands for alarm. It's just you can't really display an R and an M on this display. Yeah, you turn off the alarm by pressing the rotary encoder. And for quite some time I've been using this watch as my main alarm clock, and it hasn't failed me. It's pretty reliable. This watch uses an internal real-time clock module and an Arduino Nano, and this display requires 17 I/O pins, which the Arduino Nano doesn't have, so it also uses an I/O expander to make sure it can fully communicate with this entire display, the real-time clock module, and it communicates with this expander via I2C. Yes, so it also has the calculator mode. Here you can input numbers by using the rotary encoder. You can input them in single digits if you want. But you can also input them, you can just keep rotating the rotary encoder. If it's sometimes faster to just keep rotating it if you want like a 16 than to do it in 2 digits. If you want operators, then you need to touch this button, and here you have a decimal point. You have a delete, so you can delete some numbers. You have the plus symbol, you have the minus symbol, you have the times symbol, you have the division symbol, the power symbol, a left bracket and a right bracket, and an equal sign. So if you put this equal sign in, it will display the result. So 7 equals 7. This is pretty trivial. So we can try, for example, 71. 71.1 minus you can also input negative numbers by just rotating the encoder the other way. Minus 10 equals 61.1. And you can, if you input several operations, it will actually perform the correct order of operations. You can also assign your own order using the brackets. So 71.1 minus 10 times 2 equals 51.1. So you can see it works. We can open the inside. For that I will turn it off. Here you can see the Arduino Nano board. It is at an angle, as you see. It took me a long time to figure out the most optimal layout to make all the components fit in the smallest space possible. It's still quite thick, but it's not nearly as thick as my first calculator watch. So the first watch was actually too bulky to carry around. This one is still a bit bulky, but I've carried it around on many occasions, and it's on the big side, but it's not too uncomfortable to just carry around normally. Here's the buzzer. This is the I/O expander. This is the real-time clock module. This is the rotary encoder. And this is the display with all its current limiting resistors. The battery is here. The USB port is also connected to a LiPo battery charging circuit, which is this thing wrapped in electrical tape. So when this is connected to a computer or to a phone charger with this USB mini cable, it will charge the LiPo battery. This case is made of a brass sheet. It is soldered, as you can see here, and those are brass nuts also soldered here on the inside. These are just steel screws. This is a normal watch strap, and these touch buttons are just enameled copper wire glued with super glue to the case, but the enamel insulation is scrapped from this side. So when I touch it, I close the contact, and there is a 10 mega ohm resistor. So human body has a resistance of a few mega ohms. So when I touch it, there is actually more current flowing through me than through that resistor. So that's why Arduino knows that I have made contact with this button. So yeah, this was a very fun project to make. So thank you for watching.